Mute. You need to unmute.
Yes, sir. I was instructing my team actually. Thank you, sir. Thank you for hearing. Okay. To introduce you all on behalf of Calcutta Institute of Science and Management College, situated at Kolkata. I am Ms. Ritwana Das, is Assistant Professor of English, HOD in charge of BSc Data Science, and now the convener of the council, that is Institutions Innovation Council, and who is very, very elated to wholeheartedly into honorable resource person on the session, that is the online and offline, that is hybrid mode workshop on AI 4.0 tools for innovators and entrepreneurs. Now, let me introduce the speaker. Our honorable speaker today is Professor Dr. Sanjay S. Pawar. Dr. S. Pawar done his master's degree, that is MA Communication and PhD Networking from Department of Electrical Engineering, Indian Institute of. He is working as a principal of BCREC, that is BC Roy Engineering College, and founding director of BCREC Artificial Intelligence and Emerging Technology Foundation. He has total 32 years of experience teaching, research, and consultancy. The area of interest is augmenting AI and cybersecurity, 5G or 6G wireless networks, digital in future networks, and smart manufacturing software, fiber optics networks. Recently involved with designs and development of various professional and commercial projects as a chief technology officer or consultant with public sectors and corporates such as Vilai Steel Plant situated at Durgapur Steel Plant, Nerolac Plant Paints, Maruti Suzuki. He is also part of corporate training team in the areas of emerging technologies such as 5G, 6G, telecom and cybersecurity, digital twins, automation and optimization, etc. He has been in several countries such as Singapore, UK, Dubai, etc. He has around 50 papers in international journals and conferences to his credits, out of which 4 papers or projects have received Best Paper Awards in reputed IEEE conference as a co-author with his research. Total 6 research scholars are working for PhD, out of which 5 students have completed the PhD in the area of IPv6 low power personnel area network. Small cell design for 5G software defined storages and software defined networks. He has an institute for budding entrepreneurs and talks in the conferences in the area of 5G or BE5 security issues in networks, AI/ML. S. Pawar is a senior IEEE member, IEEE Communication Society member since last 25 years and held various positions. Member of PRSI, ISTE, etc. He is also a member of future network groups of IEEE and various subgroups such as security, AI/ML, edge computing, blockchain, and emerging technologies. And I am really elated and honored to have him as the resource. Without wasting any more time, I would like to request our esteemed speaker to deliver these meaningful addresses in front of us. Now, sir, the virtual stage is yours and it's over to you. Thank you.
Introduction. First of all, my voice is fine. Just correct. Are you able to hear me properly, or is there any lag in this case? Is my voice fine, or is there any difficulty?
Yes.
Fine. So in between, if you feel there is a lag or if there is a disconnectivity and so on, let me know. First of all, share my slides.
এই পিয়াল এত কথা বলছিলে কেন? হ্যাঁ, গোটা সেশনটা তুমি জ্বালালে না, এই সেশনে আচ্ছা, এবার লক্ষ্মীদাকে ডেকে নি, দিয়ে ঝটপট ছবি টবিগুলো তোলা হোক, তারপর আমরা রেকর্ড হচ্ছে।
Just hold on. Are you able to see the slides?
Yes, sir.
Okay. Just hold on, because I have opened. Thanks once again for giving me an opportunity to talk to the people, all you people. I'm not much more, but I assume that people have and I will try my level best to not to make much more technicality, but maybe from the understanding aspects point of view. And in between, if you feel there are queries and questions, always you can ask me. And so known today, and it is the most significant part for us as in Indians when we consider in consideration with, and this matters a lot for us from our own consumption point of view as well as the export orientation point of view. So my content will be first I'll be introducing, then I will just give a brief of what has happened in Industry 1.0, what has happened in 2.0, 3.0, how the transition took place and under what circumstances the transition took place. Then the real part is Industry 4.0. This is what presently we are into this era. Though Again, in India, I am not sure whether 100% industries have taken to Industry 4.0, but let's say 20, 30, 40% are there. So what is it? What does it mean? How does it mean to us as a consumer? What does it mean to India as a country? What does it mean to the industrialist? So in this case, the use cases, and though the topic was 4.0, but again, as we are moving ahead from 4.0, we should target. So what are the things related to 5.0? How the technology will lead to the 5.0? And then at the end, some of the questions from the audience. Try my level best to. Now, considering the industrial revolution, so the slide shows up to 2016, but after 2016, also lot many things references here. So usually, though it is shown 1930, but again, the industrialization started a bit early also. But from the technology orientation point of view, first computer, then we had an internet in 1968, 1991. We had a processors where we call it the chip integrated circuits, which started with the basic one. Today we have a lot many complicated things. That was in 1971. From the processors, we had a machine computer, which we call as a IBM today, 1981. Then World Wide Web, where the web, whatever we are, almost all people are busy with and involved with 80% of our time, www. It's 19 phones, and after the smartphone, are interrelated things. So initially, when we say we have a zero, just like BC, etc., and so on, before year zero, this was a first mankind and human age. Then industry 1, we started with an industry mechanic. In industry 2, we have an electricity and the mass production. These are the titles for those eras or for those generations. Industry 1.0 is meant for or known as a water, steam, and mechanical production. Industry 2 is meant for electricity and mass production. So in one, it was not a problem. It is meant for the electronics and IT automation. 4 is related to the Internet of Things and industry. So we started with the mechanical, then with the electrical, then with electronics and IT automation, and then we can here have a computer or maybe Internet of Things, etc., etc. So those are evolution rather than evaluation or evolution of our standards. What we did. So when we say Industry 1.0, it was an 18th century. Our engines were there, where we had a mechanical production moving away from the cottage industries. So some kind of an industrialization came. So before this, everything was a local level, cottage level, small scale level, not a very high scale level. The discovery, the mass production and assembly line came into picture. In mid-20th centuries, we have an electronics, ICT, the automation and optimization, some part came into picture. Of the industries, conventional industry 3.0. And Industry 4.0. So a lot of scope is there, a lot of what is the finance point of view. But each of this era is being represented by some kind of a symbolic representation. So you can say here a mechanical thing, then you have a, and then you have we can say. So what was it, first of all? What is industrial revolution, or the standard refers to? So we always have a standards. In fact, I am also part of this 3G, 4G, 5G. So we always know what is 3G, 4G, 5G, and so on. The name is there. But technologically, what does it provide? So what does it mean by a standard? It deals with some kind of a expectation, some kind of a property, some kind of a physical or thing happens to the standards from industry point of view also. So refers to an issue that generally is acceptable and used within by an industry. What are the domains here? Either it's a healthcare sector, we have an automotive industry kind of a standards, and worldwide they are varying. You also have a food and beverage processing, information technology, and construction industry. So these standards are related to all these industries, and these are developed over the time depending upon the market participations. Started with the industry 1, then you have a 2.0. We usually call industry 2.0, 3.0, 4.0, and 5.0. With some kind of hierarchy or a Venn diagram, we call also that as a Venn diagram. So I'm repeating the same thing. Industry 1.0 was the steam, power, and mechanism. With respect to the electricity and assembly line production, when a mass kind of a production came into picture. 3 dealt with an electronics circuitry, a chip, electronic circuitry like. 4 dealt with the computers, automations, optimizations, robots, etc. And then today we are in the world of what is an artificial intelligence. If we have a time, we'll spend some time, or we'll spend some discussion on Industry 5.0 also. So these are again the Venn diagrams, which electrical thing, then an automation came with an electronics, and then the digitalization came into picture. So the same timeline has been considered. So when we say Industry 4.0, it usually deals with also what is called the cyber physical systems, which is an Internet of Things, networks, those areas. So once we are into the brief of each of this topic, probably the things will be more clearer to you. Why? Why the standards are there? So as we see on a various equipments are there, either it might be electrical equipment, or it might be telecommunication, as in the case of wireless pin or 1G, 2G, 3G, might be in the networking point of view, might be in the standards point of view. So why does it the standards relate to? Or sometimes whenever the standards variously. So why do we use the standards? First, to or when we try to have an integration or build, adopt certain systems, because multiple people are using, there is a reduction and the integration costs are there. Then you also promote the interoperability. Efficient use of resources will be there. I'll give some examples of this one. And then usually of physical to digital. Industry 1.0 to till from the physical move to the digital version, and from the digital version we have an are there today. We'll go into at the last part of our session of this one. Okay, this is again movie where you can see such kind of a pictures. This is what maybe, as I said, most of have seen such kind of a engines. I have seen this kind of a engine running, but I doubt if anyone. This is what Industry 1.0 is there, 1.0 is there, where a mechanical version. Industry. This everything was a levels. It was in the era of 1750 to 1840. It refers to the first industrial revolution, mid 18th century. A steam, which were factory centric, and investment now. So in this case, previously local, but because of this, people started gathering at the first place, starting some kind of a production, and that's where the industrial things or inequalities from. Let's forget about those things. So this poor working conditions. So because of the previous conditions, some kind of an industrialization, specifically from the agricultural point of view. Then comes again the next 1923 emergence of technology, and that's where now initially it was a production mechanical into picture from the mass production point of view. So started something from huge mass production, which point of view, and this made a product bit cheaper because so faster as the electricity was there in that case. Previous the things started moving a bit faster and the mass production came into picture. So this is what again the era of where you had what is called as the assembly line. So we see either in a mass production, assembly lines are there, sequences are there. So that's where the assembly line concept came into picture. Ideation, amalgamations from the line efficiency, technical power, rapid delivery, all this new concept came into picture. That was in, and then World War was going on. Benefits here, it increased the productivity, improved the working conditions, moving from as a Mumbai mills, or here the textile mills are there. A coal here in this sector, this area. Automobiles production, steel and textile, that were mostly for us also, and Indians are well known to this sector. Power replaced by the steam engines. Assembly line product increase the worker point of view. And urbanization, that's where the cities started developing. A bit of a digital era we call, which is also called as an Industry 3.0. It is called as a digital revolution, electrical revolution, a digital revolution, where computers were introduced, robots were introduced. Now, when I say robot, there is also an evolution of a robot. The kind of the robot which were there for 15 years before is something else than the robot which we see today. What is their generation? What is the difference? Again, at the end part, we'll look into. But here, as I say, the computers were a part. You will be able to see a computers in industry. You'll be able to say robotics in an industry where some kind of a communication was done in terms of a digital digits, what we can say as, and that is where, and some kind of an automation level was there. So initially we had an electrical level, now we had an automation level, and because of the computers and because of robotics, rather than human coming into picture, the machines were used, and that's where the automation came in. The concept of a cloud computing, the concept of the software load efficiencies, that came into picture. Other consumers focused creation also were like cheap air travel, social media, the rise of a mobile phone, the electric car. That's where a 3.0 came into picture. Again, you can say 3.0 is more or less is equal to or led to wireless communication 3G, we can say tentatively. This is also, again, old version. If you see this kind of monitors, again in the movies, a couple of days before last month, I was in CMERI and I was visiting one of the lab there. And they had showed me, it was a big typical lab where the temperatures and pressures were quite sensitive. And they had, which was, I was really happy to see this old things that by remembering this picture, I remember those cases and so on. So here, the automation was there in effect, replacing the humans to improve the performance of the task. To the analog system that was coming into picture. Historical context picture here. I'm not sure whether you are able to understand, but probably this would be some kind of a telephone exchange where the manual operations are there or some kind of a mechanical operations happen from the production hallmark, adoption of electronics and information technology, and automation began replacing manual labor in many repetitive tasks here. Now here the concept to concept came into picture here. Was automation. Automation is where in completing certain process. So industry 3.0 refers to the use of a control system such as computers, robots, process the machines, where the human interference. Best example which you can see is, if you remember the again old movies, if you need to the booking of a trunk call means you would talk to the operator there where the human was, and he would wait till the trunk is free and then connect and then say, okay, your phone is connected. That's where the human interference came. That was being replaced. So today we don't have that one. All the switching is done automatic. Automation also paved the way for material. So the efficiency in utilization of our resources. The resources might be from the raw material point of view. The resources might be from the human point of view. The resources might be from the power point of view. Those started optimizing and automating. In addition, where so instead of human being present for testing, you can see from the robotics is the food factory Probably most of you, there is always some kind of from the food factory point of view. That's where the robotics comes into picture. Industry 3.0. When we say perform, they are mostly from the mechanical and electrical point of view. But only thing what it added, the benefits, not in human. So it could enter the environment where the human could not go, specifically the hazardous environments where the people was very difficult to go there. I again remember on WhatsApp it was being viral, where there was a huge tower, maybe 500 meters or more than that. It changed at the top of the tower, and that human who changes that bulb charges maybe $1,000 to only replace that bulb. And that video is that maybe you can check it on YouTube. Or that time, human was required to replace those light or tubes, but because of the robotics, this has been changed. So, what are the flavors of industry? Full-fledged factory automation, where the automation versions are seen. Leveraging the electrical mechanization, that means converting some kind of here, and the microprocessor-based system started. Before the computer came into picture, we had a microprocessor-based system. You have a development of an industrial robotics and the supercomputers, where it was being mentioned as the first supercomputer, second supercomputer. There it started against some business supportive system. We call it in technical term as a OSS and B. We knowing SCM. One of the example we'll see SCM, supply chain management, ERP, enterprise relationship managers. OSS, we call also that as a business support system or operation support systems. So OSS is an operator support system, and BSS is a business support system. So when the basic things are how the computerization would help, this comes into picture. And that's where here in 3.0, the arrival of World Wide Web came into pictures in this era. Now, when we 0.0, and for all of you, come across some kind of an industry, most of them are still, again, not a public sector or well-known one, but those who are cottage industries or village industries, they are still into 3.0 or less than that version. So here 3.0 is the age of an automation, where we thought of a 4.0 is the era of a smart manufacturing. Now, when we say smart, there are many things, and that's where the real technology. Industry 3.0 revolutionized the manufacturing and integration of a computers, where we had a PLCs. We defined the logics for certain operations, and then it was working automatically. We had a control systems for controlling the quality, the controlling the production, the controlling the actions, etc. So we call it the control systems, or closed loop system or open loop system. Here we started a bit collecting the data, or data silos, we can say, disconnected systems, hindered the cross-departmental collaborations, leading inefficiencies. What were the problems in this case? So so when we say a digital transformation, we are not collecting the data, or if we are collecting, it is only from the presentation point of view. We are not utilizing from the production point of view. Then what we have limitations from 3.0 is limited real-time insights. So we had at a computer, we had in PLCs, but were we able to take decisions which is a real-time scenario? That was not possible in 3.0. Again, the scalability issues came into picture. We have seen many industries here where if you want to expand those things, my present system will not allow me. But when I speak, let's say as an example, as I always, I also work on a 4G, 5G, 6G and so on. In case of a comparison of 4G, 5G or 3G, we can say, if you want to start new connection, 3G or less than that, it could take maybe 3 months, 4 months after applying and getting the real results. But when we consider today's scenario and when you apply, in fact, rather than you apply, all people are coming to your desk and saying that these are our solutions and this is what the plan is there. Please start it. We will activate now itself. That's where the difference. The issue of scalabilities. There was an issue of the expansion, but the automation up to certain level was taken care from industry point of view, 3.0. But when we are 0.0, where we term this as a smart manufacturing, to considerations, the integrating digital and physical systems. That's where physical system is there. Across what is called as a cyber physical system and so on. So when a physical system which is interconnected is on a net, call that is a cyber physical system. Some definitions will be there afterwards also. This is again Internet of Things. I hope all of you are aware, but this deals with the sensing of the parameters. It may be a pressure, it may be a temperature, it may be a water flow, it may be a sunlight, it might. Sensing this and sending it for the actions and processing is what Internet of Things done. EIML, predictive analysis, efficiency, reducing also. EIML, today, there you could not find any device, any system, any method where algorithms, this thought process are not being used. We started generating a huge data. What I should do with data? Can I for my benefit purpose? That's where the big data and the cloud computing came into picture. And then last, as I said, in the 4.0 standards, we have a cyber physical. Each we'll discuss. Cyber physical system, it's a digital and physical components work together seamlessly to automate and optimize the processes here. Now here, that's where the comparison comes. Probably, I hope you'll be able to visualize this. When you compare the 3.0 and 4.0, from the process point of view, Industry 3.0 works for the automation, means a manual interference was bit less. But in case of 4.0, we are into an autonomous decision-making point of view. Means the system makes a decision. Human doesn't make a decision. Technology, it's an industrial robots. But here, it's not a single robot, it is a swarm of a robot. Maybe I will show you, if I have a time permit, I will show you some kind of a video which shows you what are the collaborative robots and how they collaborate each other to complete one particular swarm of drones or swarm of robots, you can say. Probably you might have seen some kind of a scene, either in an Olympic or in India also. There is one company, Delhi-based company, which offers swarm drone-based 3D pictures on the sky. Industry 4.0 comes into picture. Production planning, it is from the demand forecasting point of view, working from the demand forecasting point of view. In Industry 4.0, it's not forecasting, but it is working on demand. So you have a capacity to manifest upon demand itself. That's where today's most of the industry not keep the products ready and to transfer. No. For a vehicle, you need to first book this one. And based upon the system, so you start planning for the production depending upon the demand. In previous case, you market or you product it by mass production and then distribute. That's where the difference came. Alignment, interconnection of the production process. So sequencing from one to other, one to third, that's all. Within an industry, I can say. Here, interconnection of the whole value chain is considered and so on. Just with DSP, etc. and so on. Value chain deals with what is the raw material and what is the end product. How they are interconnected. So here, when the different products are considered, what is the product? How whole chain is automated. And for that automation, we are working on some kind of the system interconnection, but a connection between one input to another input. But in this case, it was a variation, delimited variation, individually unique product. I hope you might have heard the name, a customized product. So Industry 4.0 started the customized product. That you design it and then with the 3D printing and whatever it may be, you can say also unique kind, which is exclusively for you itself. So you might have seen also there are some kind of a limited edition products which are being exclusively taken by some people as a brand, and that's where the unique product came into picture from 4.0. A goal is for the efficiency point of view. In 4.0, it was from the flexibility point of view. In this case, it was the selling of a product. It was from the servitizing from the product point of view. Now, this were some different kind of a criteria for characteristic approaches of those two things. What was the mindset of the Industry 3.0? It was a legacy approach. Legacy means what is being happening previously. Just follow those cases. In this case, Industry 4.0 is a modern approach. When you compare this compare these parameters, efficiency and stability is focused. In 4.0, future is being focused. What is expected from the future point of view? What is how many orders are there? What is the order in month or this month, next month, etc., etc. to define the products, etc. Digital first. Experience-driven decision making means you are depending upon what experience. But in 4.0, it is making a, and this is what we also have delivered one of the project in steel plant, which gives you an indication that the product is, if these parameters are not being checked and so on. That's where the AI-driven decision making ability is there. But in this case, it's a smart and adaptiveness is there. A historical history. Just agility of those things. Agile configuration, agile architecture, which we can say that. It is a transactional engagement, one time, one size. It is a personal engagement exclusively for you. So the particular product is exclusively created for a person A, person B, which doesn't have a second model or second value. And so you work for the capital expenditure driven point of view. It is based on Industry 3.0, is based on what is your capital expenditure. But these business are working. So when you consider the today's business model, or specifically a technology model and so on. So let's take an example of, I think you might have heard today, we are fighting the monopoly of a digital world of a US company such as Facebook is there, Google is there, or technology manufacturing, NVIDIA is there. And then we are now cautious about ourselves, saying that I need to ensure that my needs or the digital needs of an Indians are being taken care by the Indian and the company by the Indian. At present, no, we do not have anything. And that's where the once someday people will find that these technologies are coming, these Indian products are coming, and probably they may dilute the usage from the regular one. And sorry. So when we say a continuous funding and improvement, depending on what is the product, depending on what is the futuristic need, depending on what is the potential, the funding and improvement happens. But in case of 3.0, you have 200 crores rupees, you start a company, you start a manufacturing, and then finish. But in technology product these days, that's where the 4.0 comes. The concept is from the continuous funding, improvement point of view, etc., etc. Now, this is how the sequence 3.0 to have an industrial edge, state-wise laws, or you have then S3, AWS, Amazon Web Services. So this is a simple representative how agentic part, or rather than agentic, we can say, at present we can say AI. This also. It is not easy. It is not easy. That is the reason I said again, not all have been transformed themselves to 4.0 from 3.0. What are those? One, a fragmented data issue. So in 3.0, there was a cluster of a data. So whatever the data was collected was in a fragmented manner and rather than just produces. So let's say, what is the meaning of a fragmented data? Let's say, I hope all of you know what is called as a construction bars. I'll give an example of a steel industry here. Construction bar, So this is being manufactured by the DSP. So to manufacture the construction bar, what I require is the bare raw iron. Before that, iron ore. From that thing, we also call as a pig iron. We get a pig iron, which is the base one. That is being fed to different machines, and then the manufacturing. So in all this process, there was no collection of an information of a data from the iron ore till the product is there. But they were separated and they were only on a paper, not utilized for the intelligence purpose. So what was being done in this case? Implementing the cloud-based centralized data management was being used or is being proposed to be used to have a seamless integration. That's what. So to observe the variation, to observe the intelligence. Data science is more important. Big data is more important. And that's why we also call this as a data is a new fuel. And that's there. The people or the companies like Google, the companies like Instagram, the companies like, and they are one of the top companies, and of revenue come from India. Then you have a limited real-time insights, means I didn't have, so I can have the result and analysis of what has happened in the last month, what has happened in the last week, but at present, what is my efficiency? That is not there. That was not there in the 3.0. Automation was there. Optimization was there. That's where I said we were okay. At this time, what is the problem? I could get a real-time decision sitting here in my place, and my plant is there maybe 500 to 600 kilometers from here to location, Durgapur, or not Durgapur, also maybe from village, etc. as well, or even here in Durga. So what is the solution? You analytics to have an insight of a data, and then work from that point of view and take a decision. Integration was a difficult issue because the systems were legacy systems and they were not. You have a solution providers which could integrate the old to new one, and that the seamless transition was there. And then scalability and challenges issues were that how do I expand? So these days you can see that most of they do not have their own data centers. They are hiring hardware specification server or any other service provider and pay them for having an IT infrastructure. That's where the solution comes into picture. So here I would use or I will use the solutions only, or I will use the infrastructure depending upon how much I require only. And that's where the utilization come into picture. What are the strategies or data standardization integration? AI and predictive analysis are there. Challenges from traditional manufacturing system to real maintenance leading unexpected downtimes are there. So what I do is we are also working on a predictive maintenance point of view. I'll tell you an example what is a predictive maintenance point of view. In an industry, you might have seen the conveyor belts are there where they carry a coal or raw material from one point to another point for a 500 meters or half a kilometer or more than that also in mining. If that belt snaps, so you can imagine a 500 meters or half a kilometer big belt of a half a meter diameter, a half a meter width, and the raw material on this belt damages, and it takes 4 to 5 or 6 hours to maintain that one. Downtime per hour is lost, raw material. That if I put a system where I can continuously monitor the belt, conveyor belt, and if I track the condition of the belt, and if I feel that 90% of it is damaged, collect the raw material, replace the belt or repair the belt and start. That's where the predictive analysis. And it's only an example, but it happens in almost all devices. Cloud-based solution is scalability. That's where on-premises, on-prem, used. So if for the scalability purpose, you can use a cloud-based solution instead of on-premises. So here you have taken and how the things work into and 4.0 standards. You have a sensors and equipments here, lowest level we can say. A predictive maintenance alerts are there for the motors. From this predictive maintenance, I can identify the downtime and power usage and data from the process machine. So I get the data from all this. This data goes to a point where a lot of data is being stored from almost many of these things. You do the analytics part. So I think what is the load of a current? My motor is heating up, because what happens in a motor starts heating. So based on this, I have an analytics, and then based on this analytics, I take a call. Apply the algorithm for automation solution. It means that I work on an anomaly detection. So these are again the tech term. Those who are from computer science, you might be aware of those things. Anomaly detections. And take a call if there is a deviation from the standard values. I get a flags and then corrective measures and so on. So this is how the thing is work into the Industry 4.0 standards. So what are the benefits in this case? You uplift the productivity, enhance the quality of the product efficiency, and fewer operational costs, reduced operational costs are there. Less wastage, less downtime, few quality because of the automation and data analytics we do. We have a better customer experience. This deals with if I'm able to show a product to the customer at its own premises, and my product VR or through video conferencing. Product, then utilizing products, etc. All those services come into picture. That would help the better CRM, we can say. Boost the level of profits, because at each level, I'm able to identify what is the input cost, what is the expenditure, where the losses are made more. So I can boost the profit level considering at what stages what is happening, and then take a call from that point. Spend less time because of the automation, because of the monitoring, because of analytics. The downtimes are less, the preventive measures are more, and corrective measures are more. So in this case, it increases the automation, lowers the time consuming tasks, concentrates on the complex task also. What are the benefits? You adopt the technologies resulting in this. Because of the 4.0 and because of you have a visualistic data on your dashboard, you can make a faster decision. That's where the real-time data had proved that the accuracy 50%. You have an enhanced efficiency. Automation streamlines the production workflow. minimizes the errors, and optimizes the resource usage also. And then there is a reduced downtime, as I had given an example, the reduction in downtime is there, and I can increase the scalability. Of the industry 4.0. So you should be able to read those are there. So we'll come back to those part again. But what are the technologies involved into the 4.0? One is robotics. Instead of a human, a machine robot is there which is working. Second is a cloud computing. Instead of having your own computer for the process, you use a cloud computing, which will define the efficiency of cloud computing. You have a large is what the big data comes. You are using an artificial intelligence. You are training a system with a sample data. And when this system learns from this sample data, then automatically if similar input comes, you get the output. So again, if the time permits, I can share some of the slides for being understood as well. You have an VR, AR, or you can imagine just these days we have head enter into the of virtual reality and start working. I'll show you an example of a digital twin also, how it works. What does it mean? So by means of digital twin or AR, you can have a head-mounted display. You will go into that area of a company where that and control those actions. That's where AR, VR augmentation is there. You have a simulation. You have a cyber security, the most important. Integration, CPS, again, is a cyber physical security. It is Internet of Things. IoT is a industrial Internet of Things. There is a bit difference. So these are some of the technologies that are being used for the industry 4.0, or to implement 4.0, these things are necessary. And that's where I just said why people or industries, some of the industries are yet to move to 4.0 is, do they have all these things? What is the amount of cost needed to have all these things? And how many humans will be replaced? Probably this is an a money point of view. What is an investment needed? I go to the industry 4.0. When you integrate all these expenses and product, of course, financially be feasible. So what are the trends and novelties toward the industry 4.0? We say open source software, Linux, and so Linux is an open OS, which is a free version, that is proprietary, are being developed by a specific company and on paying of certain communication protocol, the way with which you can communicate to the devices, because 4.0 items of a system. It might be a server, it might be a sensor, it might be a networking device, IoT open source and hardware and software, remote access via web or app. So you might have heard these days, or even I was working on some of these products of Honeywell or Siemens or Bosch or many other companies, where they have a product from the security point of view, and their apps are available on my cell phone, and by means of app itself I will be able to control the operation of those. That's where the remote access web application comes. That's where cyber security or cyber uh, industry 4.0 comes into picture. Cyber security measures in an operation of an industry. What are the measures? There are certain standards. Are you considering the security measures as per the standards or not? So what are those? That's where it comes into picture. You have an augmented reality, virtual reality. I'll show you an example of what are the meaning of this AR, VR are there. Artificial intelligence, blockchains, a digital twin, and alert through message apps. So these are the technologies. Combining all these things will lead to what is called as the industry 4.0 here, standards and so on. When we consider the applications from this point of view, so one, advanced robotics, autonomous cooperating industry, sensors and manufacturing, like a 3D printing. In my campus, I have around 4 crores of lab here, which we have lot many products I can design. It might be in the industrial sector, it might be in an educational sector, it might be in so we can manufacture, we can. It is called as a additive because I do not waste any material. What is non-additive means what? If I want to modify, if I want to, let's say furnitures are there. Okay. So when you have furniture, what happens is you take a bare raw wood and prepare it. The carpenter does that. So in this case, it removes certain things. That's called as a non-additive. But in additive, you do not remove anything. Based upon certain things, you start adding this. This deals to AR, VR. Might have seen some of the movies which deals with the 3D movies and AR, VR. Maybe today we have a lot of devices which gives you an augmented reality, assuming that you are entering into the plant world and controlling those actions. Simulation helps today a lot many things, or 80% or 90% of, and most of the, and then only the real scenarios or real practical implementation are there. You have industrial IoTs. When I have an infinite sensors in an industry, that will lead to me a controlling of this action. That IoTs are there. Cloud service. So these are some kind of applications in 4.0. This is an example of a cyber physical system. System health monitoring is there. Structural health monitoring is there. Track and traces are there. Remote diagnosis is there. Remote services are there. Remote control is there. Point of view. So this is one of the application area. It comes CPS. These are new things coming into picture. Cyber physical system and automation, optimization, and autonomous decision being taken is coming into picture as well. A question again to all of you. I have not named any of the items here. Probably you can start thinking yourself. What are those items in this case? What probably this means, what is the symbol of this relates to? What is this related to? What is this related to? Some of these symbols were there in our previous presentation also. What this means, what this means, what this means, etc. Identify yourself and try to is this one question maybe after also we'll have, but still, what this symbol is related to? Maybe you can type in a
Wi-Fi
comment.
networks.
Yes, correct. Thank you. The most important part of a O is a big data and analytics. Now we are entering into a specialized area. Those technology areas, what they do, and how do I visualize? They come into picture. So why do I say a big data? What is the meaning of a big data? What does it mean? Let's per second, the amount of videos uploaded on YouTube servers. You can imagine how many these are there also. So per second, I'm saying per second, infinite. Now, what is to be done with these videos? Let's say what Google does with all these videos. That's where the analytics role comes into picture. Who has uploaded? What is uploaded? What is the language? Who would be using? Just like, let's say today, I'm giving a lecture on Industry 4.0. Who should be keen on this content? Who would like to excel practice in various areas, or to be a professional or some kind of a research areas. That's where the big data comes into picture. So when I say big data, how do I collect it? What is the technologies involved? Where do I connect it? With respect to this presentation, how do I check? So when I say big data, V, all these three, in fact, there are 5 V's, but here V is there. One is volume, another is velocity, and third is variety. These two are very, very fastly. So when you are able to check this, no. So how do I convert those huge datas? That's where the visualization tools are there. Things forms a part of a technology, which is a big data and AI analysis, which includes a capturing of data from the assets. From where? From the equipment, from the IoT-enabled devices, from the various sources, and then fed it to the example of a customer review. It can be a temperature, it can be a GPS location, it can be a customer location, etc., and doing analytics. This is one area where for integration. So what I mean, what is the meaning of integration? I hope you have heard this name, horizontal and vertical integration. Before 3.0 or 2.0, we have seen that also. There are one section is converting, and another section is converting the pig iron into a pellet, or what is called as a raw big. Third thing, using this billet to have a product, a different kind of products. So different sections are there. How do I integrate those pieces? So what is the necessary of this integration first of all? So this is where the integration is. So it is an essential framework for 4.0. Example, the production flow across the entire chain supply. What dealing with the data flow from shop to floor, top floor, back again. And production is tightly integrated with the business and R&D like those cases. And so it relates to the data of the R&D, the quality assurance, the sales, the marketing, the other departments. First of all, why it is necessary for integration and what are the horizontal and vertical. So when I say vertical integration, a distributor, a wholesaler, a retailer. In most of the retailers, can I combine most of the wholesalers? How many distributors are there? That's where the integration comes into picture. And when this integration is there, I would be able to take a collective decision what to do and what not to do. That's where the integration is necessary. And that's where the importance of 4.0 and the integration of various sections comes into picture. I already explained the cloud computing part, meaning of a cloud computing. It's an industries are using this cloud. It provides the foundation for most advanced technologies from AI, machine learning to IoT integration point of view. And it fuels Industry 4.0 technologies, which resides the clouds and cyber physical systems, specifically core industries. So when I say core industry, core a manufacturing, a power sector, a coal sector, infrastructure, civil engineering, these are the core sectors. When I say technology, it is just like a Facebook, social media, NVIDIA, IBM, HP, etc., etc. So these are the classifications. What are the things related to the cloud computing? Where the storage is there? How much is the storage? Where is the server? Where do I store this one? Whether it is a public cloud or whether it is a public cloud or the private cloud or the hybrid combination. What is the mobile? What are the applications on this one? And where is the database? So in cloud computing, these are the different sectors which are involved. So application provider will be someone else. Service provider will be from the cloud computing point of view. Here again, this is what a picture, I think you might have seen these pictures, augmented realities. In fact, when you go for AR, VR kind, A is an augmented reality, VR is a virtual reality, MR is a mixed kind of reality, XR is an extended reality. For the benefit of interest, you can go to the details of all these things. At present, when I say Industry 4.0, can you imagine of an industry where manufacturing process is some issues are there. So I wear a head-mounted display. I go in a virtual mode to the control panel, change those settings, restart and work. That's where the augmented reality comes into picture. There are many applications, but this is an example I can say. So AR still is again in an emerging field, major implications, maintenance services, qualities are that, but company, not parent company, but the company from the Facebook. And they are building a lot of AR content. In fact, I don't know whether you are aware, they are preparing or holding a virtual city. They are hosting the virtual market. They are hosting a virtual shop. The products are there. The nearby shops are being sold. You are also ready to purchase those cases going into the virtual domain. Please remember, entering into the virtual domain, going all these things, and finally, when you do everything, finally, next day morning, you will get your product. This is what AR/VR, a super visionary concept. So you go to the Meta and its product and its futuristic vision, you'll find out everything from that point of view. IoT, all this automation, control, even I said AR/VR will not happen without IIoT, which is called as an industrial IoT. It is more specifically from the industrial standards point of view. The role of them is to convert the sensing part in an industry to a digitized part to take a decision. So here, devices are there, robots are there, types to provide the real-time data about the condition and performance. Technology lets the company to run smoother supply chain, rapidly design and modify the product, prevent equipment downtime, etc. So what it consists of? Why? Why to use an industrial IoT? You can reduce the cost. You have a quality, improved quality, asset traceability, predictability, reduced error, better customer experience, and increased operations. So by using this industrial IoT, I'll be able to have various benefits, and whatever the technology I'm saying, whatever the applications and benefit I'm saying, this is only possible because of the IIoT. This is an example of a 3D printing and additive manufacturing, which deals with the material. This is what is called the subtractive manufacturing. Okay, this is a material, old material. You modify those cases, and then there is a 3D object. But in case of the 3D printing, you have a material, you have a filament, and you make the same. So wastage, you can say comparison of these two things, the wastage is a bit less. That's the difference between the additive manufacturing and the 3D printing, or that is a subtractive manufacturing and the 3D printing area. So this is a hot topic these days, and specifically into medical sectors. Even the products we have, as I said in my institute, we have around maybe I say 400 products which are ready to be sold on this 3D printing part and so on like that. Then you have an autonomous robot where the robots takes a decision. They are programmed to work in such a way that they automatically work from, or they take a decision. In this case, will be you can visit Amazon. This will not find persons more. Persons will be 3 or 4, but you will find thousands of robots which are working. Again, as I said, if you have a time, I'll show you these videos. So it will automatically take care of the decisions where the product is there, lift the product, put the for this one. And this relates with the AI, the sensor, the machine vision, and capable of performing a different, difficult, delicate tasks which can recognize and analyze those things and so on. this is another new area where a new concept comes into picture, and this is a promising futuristic area which we call as a digital twin. So I was working on one of the project with the European countries, which were saying that uh, they wanted to have the automation of the house, where the controlling of the temperatures, the controlling of the lighting, the controlling of the heating element is being automatically done. Human intervention should not come into picture. So you have two versions here. One is the real system, and another is a digital system. And the process is such that whatever the parameters in real systems are there, they are transferred to the digital system. Efficiency is checked, and if any modifications should be done, the modification in digital system is done, and then automatically it is actuated in the real system. That's where the simulation and the digital system comes into picture. It is a virtual simulation of the real world machine, product, process, or a system, and based on IoT sensors. The core component of the industries allows the business to better understand, analyze, and improve the performance and the maintenance of the system. Assets, operators, example, can use a digital twin for specific malfunctioning of a part, predict the potential issues, etc. Oh, as I said, this is again the topmost area where importance equivalent to 30 or more than 30% has to be given. So cybersecurity, because all my devices, all my sensors, all my actuators are on an internet, a virtual world, and only I as an authorized user should be able to control this and no one else. How do you ensure on a virtual world I am only the authorized person to work on this one and no one else? That's where the challenges and the technology lies with the cybersecurity. So by using again the technologies such as zero trust architectures, a machine learning, a blockchain, various cybersecurity things can be used. So let's see what are those. So when you consider, these are being classified into multiple, or when I say cybersecurity, it's a vast area. Users, it could be in the devices and devices that either the cell phone is there, or maybe a computer is there, or maybe other devices. Network means my is connected to a router, a network, a service provider. So the security issues with respect to them are there. Then my applications. So for example, banking applications are there. These applications are hosted on a cloud. How do we ensure these are bit secure or secure? And then when this is cloud is there, in between I have an edge cloud also. To improve my efficiency, I have an edge cloud. What are the roles of an edge cloud? How does the improvement? That's where the edge cybersecurity comes. So when I say a cybersecurity, security of almost all this part comes into picture. It is in terms of networking and security. It is in terms of data lake and endpoint. It is in terms of end proximity and AI. Many things are there as well. What are the solutions? How I use the 4.4 for the solutions point of view. One is a collaborative platform. Now, again, I'll tell you, an interacting with some of the people. You might have. So whenever a building is to be built, what are the steps involved into this? That I have this amount, this is my area, I want to build a 10-story building. Architecture will design this and give it to the owner saying that this is what I have planned. Owner will say, fine, this. Then it goes to the builders or the. So based upon the design that has been given by the architecture, the construction starts constructing. In between, the structural engineer is there. It will check whether the strength of the material is proper or not, and accordingly. So there is a collaboration. In older way, what was happening is, first owner will say, I want to do this. Architecture will prepare a plan, return it to the owner. Owner will read it, verify it, modify it, return it to architecture. Then 10 cycles are there. Construction will start building. After certain, it will test whether the. But because of the 4.0, I have a common platform where all the people can simultaneously do their work. That's what the beauty of a omniverse predictive mentality. If now use, so what are those assets in manufacturing? After days, Amazon and Flipkart. Supply chain optimization, which involves many vehicles, many warehouses, etc., etc. So 4.0 also plays a very important role in supply chain optimization. Time data suppliers, inventory levels, productions, schedules, customer demand. There are two different ways. One is traditional supply chain, and second is a digital supply network. So in traditional, what happens is, first you develop, then you plan, you make it, you deliver it, and then support it. In case of a digital supply, synchronized planning, customer customization, smart factory, dynamic fulfillment, digital development, and core. They are interrelated things. And so that's the basic difference between economy. Agile manufacturing, what does it mean? Again, there is a huge change in the business trends nowadays. Previously, first the products were manufactured, then to the local distributors, then to the shops, kept in a shop, and then the customer was coming. Things have changed now. Rather than this is what I want. Once this does, it goes to the manufacturers. It says this is what the raw material is required. Talks to the raw material persons, get the raw materials, get it done, and then later. That's where the agile manufacturing new version is coming. So AI and advanced analytics allows you to gather and analyze the media. And R&D team product designers can leverage the data to identify the consumer's preferences, pinpoint the emerging traits. And by incorporating the feedbacks, the design can be a unique one. Products better align with the market demands and improving the satisfaction and the loyalty. That's where the agile manufacturing is there. So you have a traditional, you have an agile here. Iterate faster, bottom up, flexibility, welcome changes. Quality into this case, and computer vision these days, CNN, computer vision, artificial intelligence, deep learning. Because these are involved, you can see only one person is checking and all the quality control happens here from the robotics matter. Circular policy, I don't know whether you have heard this name or not, but the circular economic policies are there. What it deals with? First of all, what is the product? What is the use of the product? What is the end life of the product? Can I reuse it or remanufacture it? I'll tell you an example. We are in a belt of a manufacturing. One of the way of steel manufacturing is collecting the ore from the mines, ore from the mine, processing it, getting a bare iron, and then the product. Another way is, which is the small scale people, they collect the waste product from either the industry or from remains of the subtractive manufacturing, or from what we call as a bangar, which is being collected from all over the city. They melt it and make a product. So how do you build this circular economy in almost all cases? Specifically, this is more necessary for the sustainability, the environmental, and the plastic products. So 4.0 support the implementation of circular economy, focusing on reducing the waste and maximizing the reuse, refurbishment, and recycling the material. By utilizing the big data analytics and IoT networks, you can track the product life cycles, implement the reverse life logistics products, and optimize the recovery of the resources. And AI-powered advanced analytics can also help the product designers to develop the product right from the drawing board till the end. And so that is what the concept of a circular economy comes. Carbon footprints. If you're aware, today, if one of the conditions of a government of India is of your land for a plant, how do you have a carbon? One is plant a tree, or second is, or it's both, I can say, reduce carbon footprints. And these heavy industries like a coal, mining, power sector, they, so how do you from the 4.2 point? a digital twin, sensors are there, computer vision is there, robotics control, automated logistics are not included drones because many things are there with the drone. A digital twin is done by means of asset management. By means of digital twin itself, I can have a remote control, augmented workers, and push to talk. Those things are there. Which are the businesses affected by 4.0? When the product is there, business operations are there for the product, new product and in the extensions, new business models, product development and process. In case of a supply chain, a factory and operations, supply chain networks and logistics, planning and inventory. And from the customer point of view, what is in customer experience? Selling and market, channel connectivity of all these connections, which are being affected by 4.0. Real values from the benefits. So in you see a 10 to 20%, 6 to 9% productivity increase as measured by the total manufacturing cost. Productivity increases as measured by the total manufacturing cost. So automotive, component, food and beverage industries, 20 to 30% benefits from productivity increase and measured by the conversion cost. Machinery, 20 to 30%, and others, we can say 10 to 50%. This is where the benefit. And when your business is in terms of millions and billions of dollars, you can imagine how much of the things will be shared or saved. This is again the same I had included this slide again, so that we can also imagine what this relates to. So whatever we have discussed in a brief was with respect to 4.0, where systems with IoT, AI, cloud, and data. There's a human-machine collaboration and hyper-personalization. That's where the new version comes. So people, if you are into an industry, if you are into research, if you are into a professional practice, should concentrate more on related areas. Though not all industries implemented, but it's a mature technology. But think from 5.0 point of view. When you compare, when you focus from the focus point of view, it is in terms of automation and technology for efficiency. And this is for the process. Emphasis on data analytics and optimized process. Here, competencies is required from IoT, AI, technologies, and human skills creativity. Robots and autonomous machines, development of a new skills are expected. Smart factories, here integrated flexible production system. That means what? I give an order. You can imagine a system. On this case, there is a factory, or there is a, let's say, manufacturing. This is what I'm giving an order. So immediately this order goes. Printing of the cloth or stitching of the cloth automatically happens, and next day it comes to me. That's where the new technologies or development and new skills and competition among the human works comes in picture. Factories, flexible production. Technologies, digital twin simulation, advanced technologies are there from the nanotechnology, biotechnology point of view, and efficiency, predictive maintenance, etc. So here it deals with the sustainability, resilience, and it's a human-centric. Efficiency, automation, and cost reduction. In 5.0, it's a huge sustainability, human-centric and resilience. Same thing, technology. Now, when I say 5.0 technology, it's an advanced AI, where today I call this as an agentic AI or autonomous AI. Cobots, bots, augmented reality, 3D scanning and printing. Approach, digitization and interconnection. Here is a human-machine collaboration. Is a mass customization. So when I say personalization means what? For 100 people, this is clear, made. These products are made. For 200 people, these products are made. So let's say our garment, we have a size of 32, 34, 36. The new version will come into picture for X person based upon its photograph and the video. Automatically, the size comes. Data utilization, data-driven decision making and process optimization, data-driven human augmentations are there. Workforce impact, workforce reduction due to the automation, workforce augmentation and enhancement through the collaboration and technologies. That's where now you might be hearing that many layoffs are there from various companies. So the layoffs are there for those companies or those people who are not able to upgrade themselves and not into the adopting area for new technologies. As I think Amazon has been told, tentatively 30,000 people, mid-engineers, will be replaced by the robots now, because it is more efficient for them. Business means business, they look into one term and each and every pie. So accordingly, they decide. And that's where predictive maintenance, automated production lines, supply chain optimization. In case of with the sustainable solutions, with an integration with the customer and directly the manufacturer and so on. So that's what the differences are there. So here, features, human-machine collaboration, flexibility, the sustainability is there. Examples of 5.2. Companies like BMW, Toyota, factories there, no humans are there or less humans are there. Electronic industries driven by the AI driven. Healthcare and medical devices, robotic, robotic surgeries are there, robotic products. Yeah. Textile and fashion industry, that's what I was telling. I was working with one of the e-portal from that point of view. So some things we are working with respect. Or have a look towards the how many people are there and how they are working. 5.0, 1, second, third, fourth, which technologies are being involved? How there is a transition. Focuses on connecting the machines. 4.0 is, as I said, mask hyper customization. Too precise. Each and every person in India will have its unique apparel designs and so on. Intelligent supply chain, responsive and distributed supply chain. That means what? Depending upon the demand, the activation of a network comes into picture. Smart products, you have an experience activated products. Manpower, that's what the next thing comes into picture. Who are the technology enablers? Mixed reality, 5G and beyond, which I am working again. Additive technologies, exoskeletons, drones, and industrial blockchains. This is again the comparison between the 1, 2, 3, 4 in terms of the timeline, in terms of the production systems, in terms of technology, competitive and manufacturing concepts. So this is where I think I'm here today with, I think this was a brief, I have not gone into the detail, but just as a brief information, what is happening in the world of 4.0 or its higher version. I will be happy to have questions in these areas. I hope I was audible.
Sir, you are completely audible.
Questions, please.
Sir, can you please tell, can you repeat?
Sorry. Vertical integration.
Integration.
Okay. Let me go to the slide. Okay, so let me share.
I think the audio is interrupting, sir. Audio is not clear.
Okay, I was not speaking. Of the vertical integration and horizontal integration is this one. So whether you're combining, one integration is from end product to, so for example, end to end, from the raw material till the end customer. How do I integrate this? This is one area. Second case is, how many customers are there? From Eastern India, how many customers are there? How many wholesalers are there? Who are the raw material producers? So this is where the integration comes. So when I say vertical integration is from the raw material till the customers, how is the integration happening? That is what the meaning of a vertical and horizontal integration is. Yes, please.
Sir, I have one more question.
Yes, please, go ahead.
Sir, can you please briefly explain the application of IoT in our day-to-day life?
Okay, so let's say at your residence, okay, you have a fan, you have a television, you have a Alexa, you have a fridge, you have a heater, you have a gas, you have a windows, you have a door. For all of them, there are sensors are attached. Let's say at present there are not, but nowadays we get a product. Fridge is there, television is there, which are connecting, and this can be connected on certain apps. So I have a let's say Samsung TV. I can connect. Have an app over that one. So all these things can be integrated on my app. And let's say before I come, if I am going from my house to my office to a house, I need to switch on the AC. So from the app itself, I will be able to switch on the AC. What does it happen is, from my cell phone, the signal goes to the cloud. From the cloud, it goes to the sensor activators at my house, and then it will switch on the TV or switch on this one. So all this activation of the devices happens, which we call as a smart homes. If you want in the more details, you can refer to the smart homes. A lot of solutions are there. So here the IoT day-to-day life comes into picture. Second thing is, from the based upon sensing, you read the YouTube video of a food factory. So in food factory, you can check the product is coming at the end without any human interference. Everything is automated. So this is done by only sensing by the sensor, by IoT sensors and so on. The combination of the parameter from all the sensors is being taken and read, and the decision is being taken automatically. This is what the day-to-day applications are there.
Okay, I think GR Jadav's query has been segregated. So I would like to address all the participants that feedback link is live. Given your feedback in a proper way to starting your certification, okay? Next, I would like have any query regarding the session to sir. Sir will address that definitely. Now please raise your hand one by one if you have any query. Okay, Jia Jadhav has raised her hand again. Okay, Jia, you can unmute yourself and ask the your query.
Yes, Jia, please go ahead.
Sir, you talked about a topic regarding carbon footprints. So, sir, I had a question that how, like the technology as it is increasing day by day, so what will be the effect of technology over those carbon footprints? Like,
Tracking the carbon footprints. At present, we do not have or we do not use the technology. So, for example, let's say power industry is there. You might have seen this
Sir, your audio is breaking. We can't
big
hear
power
you properly.
thermal power plants. Okay, this thermal power plants a lot of ash, lot of air. Are you able to hear me? Lot of
no,
AQR, lot
sir, your voice is
of things.
glitching actually.
Wait. I think it's a combination of this things are coming. I'll answer. Coming into picture. Okay. I think now voice will be fine. Let me know. So okay.
Yes, sir.
So I'm feeling with respect to there are the tracking of the carbon footprints. So pollution is there, the heat is there, the materials AQ by means of 4.0 we can track this use, and the technology is used to track the feedback saying that this is technology will not be increasing this footprint, but it will be tracking and it will give a solution to control those footprints. And that's where IoT is. So those things are. Got it?
Okay, I think Jia's query has been circulated. Now, one of our students who is joining this session physically from our venue, as this is a hybrid mode workshop, Obi. Now, from post ID, Obi Rajo, ask your question to sir. Okay?
Sir, I just want to ask, can you tell me about something about 5.0?
See, again, 5.0 is a higher version of 4.0, where three things are there: resilient, human concentric. So you are making what is called as a personalization. All the products are made from the personalization point of view. Means, for example, as I said, I given an example. I give an order to manufacture the apparels exclusively, which is meant for my side, not for all over India from maybe 24, 25, 26 and so on. That's where the personalization comes in. And more SDG goals from that point of view. So by using the technology, personalization, and all these things, these three categories and resilient, the 5.0 or 5.0 is being taken care of. Fine.
Okay, sir. Thank you so much.
Thank you so much. I think nobody else has any further query. So thank you very much, sir, for coordinating our session and for segregating the queries of our children. It was indeed a very heart-rending session, as this is a hybrid mode session. Our students were attending physically, so I could see their intense attention towards the topic, and I really don't belong to the forte of technology, but I also was very much arrested by the PPT presentation and all that. And now I would like to end the session by thanking all the team members, that is, who were the backbone of this program, all the student coordinators. Student coordinators, please make yourself sure that you are silent enough. All the student coordinators, all the participants, and I am really grateful to Mr. Proshijit Naik and Mr. Nikroni Basu for funding this entire session and being a CISA. That is Dr. Sanjay Bali, and last but not the least, my faculty member coordinators, Ms. Ronnie Bhattacharya and Mrs. Shatomi Shamani, who helped me a lot to conduct the session. And by thanking you all, I would like to end the session. Thank you so much. We are grateful that you have came here to coordinate our session and enlighten the house with your graceful speech. Thank you so much, sir.
Thank you. I hope you enjoyed all those things and you can continue working into this area. And any help is required, let me know. Thank you.
Thank you.
Thank you, sir.
প্রফেশনাল রে বলেই কেটে দিল, আর কোনো কিছু বলবার সুযোগ দিল না। ব্যাস, ডান।